So the last part of this problem says find d squared y dx squared in terms of y. Now that looks really confusing, but that just means find the second derivative of the equation up at the top of this thing in terms of y. So this was the first derivative in terms of y. So just want to find the second derivative. And I know that if I ddx this, I derive this with respect to x, that I'm going to get this term out on the left side. So that's what I'm going to do, because that's going to give me this term, and then I'm going to have to do some work to manipulate it as we move along. I'll also say with this problem, there's, I don't know, at least like 3 different major ways to find this thing's derivative, and this is the easiest, I think, but it depends on how your brain works in terms of calculus, but all of them have their own little individual, all of those different ways that I mentioned, all have their own little individual cruxes in terms of like, well, this part's the hard part of this problem. So, I'm going to do this in the way that I think is the easiest overall. So the first thing I'm going to do is rewrite this so that I can actually use power rule to find the derivative of this thing. So dy dx is equal to, well, that thing right here is in the bottom, so I can always write that as 1 minus sine y to the negative 1. And now I've eliminated a lot of the messy derivative things that I would have to do. Right here, I could derive this with quotient rule. The problem with that is that the quotient rule is kind of terrible to do, and this 1 makes it so that I can rewrite it like this. And I always say when we're stuck using quotient rule, if I can use power rule instead, I will. So this is an example of when I can use power rule, and it will make my life a whole lot easier. So I'm going to use power rule for this. So I will ddx this. You could write y double prime if you want. I'm going to write d squared y dx squared, even though that notation is probably very confusing. Maybe I'll write y double prime over here on the left. So I have the second derivative, and that's equal to, so what I need to do here is chain rule first. So I'll do chain rule on the inside stuff. The chain rule, well, the derivative of 1 is nothing, so this piece's derivative doesn't show up. And then this thing's derivative, well, the derivative of that is cosine, minus cosine of y. But look, this is a tricky spot right here. A lot of times when I'm doing implicit differentiation, I like to write those bracketed things around y so that I can see the chain rule. So hopefully you see now that I need to write times dy dx here. I hope that step is okay. It's kind of really important to make sure that we get that step. So now I'm going to do derivative of the outermost part. So that is my power rule part. It's to the negative 1. So my power rule says, well, multiply by the negative 1 out front, and then put the back in a set of parentheses, 1 minus sine y, and then drop the power by 1. So that takes me to negative 2. So from here, I'm going to rewrite this as minus cosine y times dy dx. Actually, I get a double negative there. Do you see that? This negative and this negative cancel, so I'm just going to erase that. And then that parenthesis, this guy right here, it's a negative 2 power, so I'm just going to bump it to the bottom of the fraction and make it a positive 2. So I get 1 minus sine y squared. So let me point something out here. Here I've got an equation for y double prime, or d squared y dx. But notice in black up top I say in terms of y. So I have cosine of y, that's good. I've got 1 minus sine of y squared, that's good. But this is not just y, it's got that x in it, right? It says dy dx. So I've gotten the second derivative, but I haven't written it the way that we want to write it yet. I want to have it just with y's on the right side. The bright side is that I have an equation for dy dx from part A, or from my starting point of this problem, in terms of y. So that means I can replace this box with this box here. So that's what I'm going to do. So I get, maybe I can leave enough space. I get equals cosine of y times fraction bar. I'll make it in red so you can hopefully see what's going on here. Fraction bar 1 minus sine y, and then over, and this is being multiplied here, 1 minus sine y squared, like that. So now I'm going to give myself some more space down here. So, actually here, before I do that, just notice that I've simply rewritten this right here, except for I've replaced this with another form of it that I understand and know, and that's right here. So, I don't like fractions and fractions. If this was actually this is an FRQ. So if you left it like this, you would get full credit for the AP form thing, right? But if it was a multiple choice type question, you never know if they would do one like this. I need to get rid of the fractions and the fractions because it wouldn't show up like that, and I would need to recognize it. So I'm going to take that red fraction and I'm going to move it to the outside of the upper fraction. For example, if I had 2 times 7 over 4, I could write that as 7, this is a bad example, but I'll do it anyway, 2 over 4 times 7. I could write that like that. So this piece and this piece is going to be my fraction thing there. Anyway, so I have cosine of y over 1 minus sine y squared in parentheses times, my red thing is going to show up out here, 1 minus sine y like that. Notice those denominators are the same, so I'm going to simplify this and write cosine of y over, I've got 1 minus sine y squared times another 1 minus sine y. So that gives me a total denominator of 1 minus sine y cubed. And that is the final, most simplified answer. Although, as I said, you could write this and get credit for it on an FRQ.